Hello, my name is Daniel Nenny, and I'm the founder of SemiWiki.com, the open forum for semiconductor professionals. Since going online in 2011, SemiWiki has registered more than 200,000 active members. If you're not a member of the SemiWiki community, please register as my guest. I hope to see you there. Today's webinar is titled From Specs to Verilog, AI-Assisted Logic Design on a RISC-V Implementation. The presenter is Matt Genovese, CEO of Planorama. If you have questions, please use the question tab and we'll answer them during the Q&A at the end of the presentation. Okay, let's get started. Over to you, Matt.
All right, thank you, Daniel. This will be our discussion topic for today. I was encouraged to remind you that there will be a live demo during this webinar. So a quick bit about me. My name's Matt Genovese. As Daniel said, I'm the founder of Planorama. I'm an engineer by training. I have about 27 years, about half my career in the semiconductor industry in design and verification of processors and SoCs. The other half of my career was spent in various roles in enterprise software product development. My company, a little bit about that, I founded Planorama. I run it today. We're a US-based technology company headquartered in Austin, Texas. Planorama Design, as you can see here, is our professional services arm. We specialize in designing intuitive software and accelerating products to market, all while reducing development cost. As you can see on the pictures here, we've worked on especially complex and technical software, engineering software, including EDA, cloud management, AI applications, and AI deployment management applications, and many more. So that's the Planorama design side. Planorama Labs is where we focus on creating and products and solutions. We have our own in-house R&D and our own AI and development teams, and we focus on highly technical solutions in areas where we have expertise. Our upcoming demo will be coming from one such product. So I want to talk for a moment, and there's no doubt that you've had some experience with generative AI, at least by hearing about it, and perhaps you've even used it. You know, whether it's in images or video or language models, or companies like OpenAI, Google, Microsoft, Anthropic, Mistral, they're all in that space. And so the point is, why is it important to us? And I mean us in product development. Well, a few reasons. First of all, machine understanding of our language happened way faster than we thought. And not only the basic grammar that we use, but the nuances, the subjectivity, the complexity. It understands for the most part what we write and say. And that has been very surprising, I think, over the past few years. It's trained on, I'll say beyond all that technology innovation, beyond the idea that transformers, these transformers and language models work the way they do, and there's innovations happening there, it seems like almost daily. The language models to date, the large commercial ones, have been trained on everything we can throw at it, which is the internet. So out of the gate, it has potential beyond any single human. Individually, we cannot retain or recall all that information, right? There are hallucinations, there are shortcomings, but the technology and the mechanisms that they're creating are improving that daily to mitigate those shortcomings. So what we found over the past years is that there's this emergent capability of reasoning, using trained information to apply that in new scenarios. And this is a unique ability that to reason that in these new contexts, this is one of the single most important aspects of these models, is the way to apply information it has inside and scenarios inside to apply to new situations and to reason through them. And so what does that turn into? Well, if we couple that with the developments that enable real-time access to data, it allows these language models to augment humans' day-to-day activities. Any challenge, question, whatever it is, doesn't necessarily require the model to have been trained on it. They can brainstorm and evaluate problems as designers, developers, testers, even philosophers, almost any role. the AI has a part to play based on the information it's been trained on and its ability to adapt to new context, even when that context was not included in the original training. So what does that mean for us in product development? Well, it means that everyone's trying to figure out how to use this because of that capability, right? But there is significant potential to augment and accelerate what product teams can actually accomplish. And so that's what we're seeing. The most well-known product development tool released has been GitHub CoPilot. And I'm talking more in the software engineering space right now. It assists developers with coding, and it does a great job. I've used it. I've tested it, evaluated it myself. It does a good job. Even as a coding assistant, many organizations are reporting double-digit increases in their productivity. Other large companies who can afford to build their own solutions are doing this, right? Google was a release just a week or so ago that they're building their internal solutions to accelerate software development. Gartner and Forrester are both forecasting that there's significant changes on the horizon for software development. Now, today, AI is primarily an assistant to the software engineer. It works when the engineer works. And when the engineer goes home, the assistant stops. But there are efforts to change this. So you see projects here like GPT Engineer, GPT Pilot, Cognition. They're all pursuing this. And what they're trying to do is have AI take more of an autonomous role where it becomes a participant in the development team, just like every other person there. The goal is to make the AI, I'll say it again, behave as a part of the team in communication with human engineers and with human engineers giving oversight to what it produces. So we should remember that as more of development, as more of the development process becomes AI assisted or even automated, the specifications become vastly more important. Engineers, right, they have to refer to the specifications. Autonomous AI agents, these participants in the development team, they have to do the same. And it turns out for chips, for RTL design and verification, AI needs access to the specifications, and lucky for us, it has them, right? We have specifications written as documents, human readable engineering and product documentation. So what kind of documentation am I talking about? Well, we have data files, we have design specs, ISAs, the HDL repos themselves, verification scoreboards. All of that is data that is possessed in a single project, right? And then depending on your company, you may have your own system for housing and tracking all of these versions of documents and where they're located, right? They can be in different internal websites, it could be on external websites, code repositories. God forbid they're sitting on your local hard drive somewhere, not in a repo. They need to be somewhere accessible. But we have all this information already. And so what I'm going to be talking about today is Symphonia. Today, Symphonia, by the way, is Portuguese and Italian for symphony. We built Symphonia with all of this product related information in mind. There's no need to make copies. You don't have to duplicate the information. Wherever the information exists, Symphonia can read it, can have access to it. In fact, it even enables engineers to add verification plans directly through the UI, but I'll talk a little bit about that later. But the point is, wherever the data exists, if Symphonia can access it, then you're good to go. So now as a hub for that information, Synfonia's AI has intelligence about your product. So what can we do with it? Well, for one thing, the engineer or an embedded developer, or even customers, if you wish, they can ask questions in natural language that may span all or a subset of those documents and receive a response back quickly. Symphonia is also able to leverage one or more language models, from commercial to open or finely tuned internal models at your company. It can even determine which one is best to use at any given time. We built in this flexibility to alleviate the concerns about sensitive data exiting your perimeter, your designs, your IP, or even lock in to a particular language model service. And finally, through Synfonia's API, we have future expansion capabilities built in for engineering and development IDEs, or even autonomous AI agents. And we'll talk a little bit about that later. Now we're going to slide over to the demo for Symphonia. Here we've included, in this particular demo, we included in the RISC-V specification documents from their website, and we're using OpenAI as a large language model. Again, that's for this particular demo. So I'm going to pause here and jump over to the demo. Give me one moment. All right. So now we are logged into Symphonia. It is a web application. It works from any web browser. We have already created a project called Symphonia. I'm sorry, created RISC-V test. We're in Symphonia right now. What you're seeing is a map, and this map is just a flexible way for capturing and breaking down information. There's 3 levels in which you can break down. And in this case, we're using it to capture a portion of a verification plan. So we have this feature map here. This map is called multiplication tests. We could add other ones as well. As you can see, it's all written in plain English, right? We could have many of these documents. It's entirely freeform. I can show you that I can create other areas. So right now, let's take a look. We're looking at the integer multiply instruction test for signed numbers. We could go in and add others. We could go in to add for unsigned numbers or unsigned integers. We could add in more tests. We can move items around. The whole point is that this is a flexible way for, in this case, a verification engineer to map out a verification plan for a particular project and break it down into various areas. And in fact, you can share between. So all the verification engineers who are working on the same project can have a view of the same verification plan. So the other thing that I mentioned was that we also incorporated the RISC-V specification documents into the same project here in Symphonia. I'm going to jump over, and you should be able to see here. This is the RISC-V site. And here are the PDFs that we pulled in, these two, and they're pulled into Symphonia right now. There's not a good way to view that on this particular UI, but you can trust me that they are pulled into this particular project. So they define the specifications for RISC-V, for the ISA. Now, instead of, let me, hold on one second here. Oh, and then finally, we could include other databases. We could include other internal or external websites. But for right now, this is all we need to get started. So now I'm going to swing over to another interface. It's over here. And this one is the Symphonia virtual assistant. That's what we call this. It is basically a chat style UI that you may be familiar with if you've used ChatGPT or other types of tools like that. And it provides a natural language access to everything in a Symphonia project. That means you don't need to go and search through documents to get answers to questions. You can see we have the project that we were working with before right here. So now we're going to assume, to start out, that perhaps we want to ask some questions. We want to get some help. So let's assume we're a new engineer on a RISC-V core development project, and we're going to go work on the integer multiplication unit, which is very fortunate because we happen to have mapped that out in Symphonia. So instead of searching through the documentation, let's ask a question directly. By the way, I'm going to be copying and pasting in text into the window. It's only to save from typing because I can be horrible at typing, even though I'm old enough to be better at it than I am sometimes. But all the results are generated in real time by Symphonia. So the first question we're going to ask is, well, let's describe the integer multiplication instructions. So we're going to wait. So what we're doing now is it's pulling out the information right from the specification documents, and it's using that to produce a natural language answer about all the different types of multiplication instructions that are available. The other thing you'll see here, and I'm going to wait for it to complete. It goes through multiply and it goes through the unsigned, and then MULW. And this is streaming right from the AI. So this is you can see the tokens coming down. The other things that we have here are the source material for where it pulled some of the information from. So it's pulling from Symphonia, and it's also pulling from the documentation for the RISC-V spec. So if I click over on this one, it'll jump over, open up the PDF, and tell me, here's where it's pulling from. It's pulling from the M standard extensions for integer multiplication from the RISC-V spec, right? And I could scroll down and see more about it. So it will always tell you where it's pulling the information from, so you can go back and refer to it. Now imagine you're new to the ISA and you're thinking, boy, I got to multiply two numbers, but I'm not sure which instruction to use. We can be more specific, and we can state the specific problem we want solved and ask Symphonia to respond and help us out. I'm going to paste in another question here. If I wanted to multiply 5 times -6, what instructions should I use? I'm going to wait a moment. So it's coming back and telling us that you could use the MUL instruction. And so we could load 5 into one and -6 into the other source registers, and then use the multiplication to put it into a destination register. So there we go. It used the information that we provided it and told us what instruction to use. Now I have an exact answer for my question. Now let's go back and do something a little bit different. We're going to change gears again, and we're going to say, look, because Symphonia understands not only the specifications for RISC-V, but it also understands our verification plans, we can ask some questions about that, right? So let's go in and ask, I'm going to, again, paste in a new question here. We're going to ask it to summarize our test plan for integer multiplication. So describe our verification test for integer multiplication. And you see at this point, it is listing out all the tests that we have written in Symphonia in the interface that I just showed earlier. In fact, we'll go back and double check, right? And it's telling us what have we already written down, planned out in our strategy for verification. Well, we said we're going to do a multiply by 0, multiply by 1, multiplication of 2 positive numbers, and a positive and negative. Okay, let's come back over here. Here it is, multiply by 0, by 1, 2 positive numbers, and one positive and 1 negative. Great. Now, it's usually good practice for verification plans to get reviewed, right? To have peer reviews in your team to make sure that you don't have any gaps, right? And so what we're going to do is we're going to use our virtual assistant to assist with that. So let's go. I'm going to paste in another question here. List any verification tests for integer multiplication that are missing from my plan. Take a moment. Based on your plan, it looks like you've covered some crucial scenarios. Multiplication of 1 positive, 1 negative. That's right. So it's restating the plan that I put together. And now it's saying, oh, look here, multiplication of 2 negative numbers. This test would verify the correctness. And that's right. I had missed putting that into my plan. It's also talking about overflow detection. It's suggesting about the distribution of 0s and 1s for edge cases, as well as, look, it's talking about powers of 2, mixed sign multiplication. So it's really going through and suggesting some other areas that we ought to consider as part of our verification plan. And I'll be straight up with you. When I was putting together this demo, I had forgotten to put in the double negative for multiplying 2 negatives together, of course, to get a positive. And it came back and told me the first thing, oh, you're missing this one. And I thought, my God, you're right. So it does work, and it's going back to the RISC-V specification. using the specification documents along with your plan and looking for gaps. So now we're going to do something a little bit different. I'm going to start over. Oh, by the way, and I should have mentioned this before, those tests that it suggested, you could imagine, I mean, like right now, that was manual. I asked it a manual question as an engineer, and it went back and said, okay, here's what you should look for. You could imagine, though, that in the future, the test plan could be automatically reviewed and updated with the suggestions made so that the verification engineer can approve. And so we'll talk about a little bit about that later. Now, okay, let's say we have the verification plan rounded out for integer multiplication, and it's time to write some test cases. Let's jump in and start doing that. Now this request is a little bit longer, so instead of typing it in here, I can click on this button. It gives me a larger area to write, just so you can see it. But this is write the instruction sequences, including loads and comparisons for correctness, for each of our signed integer multiplication tests for the multiply instruction, MUL. So here it's going through every one of my test cases that I have written. And remember, I did not re-annotate back in the negative times a negative. So this is just using the ones that I already have in the test plan in Symphonia. So it's going and saying, okay, great, we need multiplication of one positive and one negative number. So it's writing a test case for me. And then it's providing a way to check the expected result. And then it will allow me to branch. Right now we've got multiplication of two positive numbers, 6 times 7, right? Multiplication by 1, 15 times 1, and the negative numbers is testing as well and multiplied by 0. So again, it is doing some work on my behalf to review my test plan and to come up with test cases that can be written in order to validate that the functionality and implementation is correct against the specification documents. Now we're going to deep dive a little bit into RTL for a moment. Let's say that I wrote a multiplier in RTL, and I want to have Symphonia, the virtual assistant, review it for me. In this case, I'm going to paste in some RTL from an open project, and I'll show you what's going to happen. So let me start over here. And I'm going to use this interface. And I'm going to paste in this request here. And then I'm going to add in some RTL. And I'm using this RISC-V multiplier that is on GitHub right now from Ultra Embedded. And I copied, in fact, I'm going to go through and just copy it again to make sure I get it. Copy the whole one. And then come over here. Oops, over here. And paste it in. Now, again, my question was, please write a review of this RTL for the integer multiplier. Highlight any areas that may need attention. So what we're going to do, we're going to play a little dirty ball here because we're going to test this out. Before submitting, I'm going to embed a bug into this multiplier. So I'm going to come down here and we're going to have the pipeline flops. And I'm going to have it reset. Instead of resetting to a 0, I'm going to have it reset to 1s. 33 bits of a 1. And then we'll go. And we're going to see if it comes back and tells us if it finds any problems. So it's talking about the pipeline stages. And by the way, it's giving a review. It doesn't mean that these are all problems. It is saying that there are areas that may need to be reviewed. Okay, and it's worth taking a look at from the RTL designer point of view. But now if we look, let's see if it actually brings up the bug. Upon reset are distinct. Worth confirming that these initial values have been chosen deliberately. That's right. So what it's coming back is saying, hey, you should take a look at that particular reset that we did because there's a 1 and a 0 and a 0. We may need to go back and review that. When I ran this before, of course, the language models will come back and state things a little bit differently. It actually just called that out as like, hey, I think you have a bug there. In this case, it's telling you to go and review that because you have everything else is set to 0, but this one here is set to 1. All right. And it also brings up some other points too. You know, it found the bug, it gave some observations. It doesn't have the access in this particular demo to the defs file. So there's a RISC-V defines file. So that's why it will make some suggestions about, boy, I hope some of these constants or defines exist. And there's a bunch of other things too I won't go into as well, but I wanted to point out that it will give recommendations for areas to take a look at. And this is, again, before verification ever runs, before a simulation ever runs. All right, now finally, I'm going to come back and we're going to do one more. Oh, and by the way, the other thing I'll mention is that I'm pasting in code here because this is just for the demo. You'd imagine that when you have Symphonia plugged into your environment, it already has access to the code repository. So this pasting in of code wouldn't be necessary. It's looking at the context where you are in your code base and can give you recommendations based on the module or where you are in the module or where you are in the hierarchy. So this is pasting in the code here is an artifact of doing the demo that we're doing today. All right, and finally, I'm going to jump over and I'm going to ask one more request. All right, because we all know that there is a great benefit of using system Verilog assertions, SVAs, as part of the design and verification process. So why don't we ask Symphonia to give us a head start? So what we're going to do is come in here. We're going to say, suggest some SVAs for the MUL instruction. And, oops, I'm going to paste in, oops, I'm going to paste in that Verilog again for the whole module, for the multiply module. So suggest system level Verilog assertions, referencing our multiplier RTL below. Great. So now it's looking at, okay, let's make sure we're looking at the right opcode. Results consistency check, operand, sign extension. And this is actually going beyond. So it's going beyond even the multiply instruction and doing the MULH and the unsigned instructions as well. So it's going well beyond. We can be much more specific in our request and have it generate even more for us in terms of the properties. So, it's easy to visualize that, it's helping right now as a verification engineer, as a chip designer, RTL designer, that it's working alongside of you. But it's also easy to think about the fact that this could be done, autonomously, reviewed against your specifications, and the SVAs are automatically proposed by Sinfonia and then available for review by your team instead of having to go in and ask the question, make the request directly, manually. So let's go back. We're going to wrap this up. And I want to talk to you about the future of this kind of automation and where I see it's going. So I'm going to pause sharing and jump over to the slide deck and then share my screen. There we are. Okay, great. So let's talk about what's on the horizon. I promised to talk a bit more about the area circled in red here. What we're calling it is AI Accelerated Design Automation, ADA, because we not only can assist engineers manually with creating test cases, But we can also imagine that they're going to be automatically created with expected results based on the specifications that are loaded in. And then when you start using stats generated from functional coverage, from code coverage tools, they can see the generation of additional test cases, and this could become a feedback loop. And so now your specifications and all those documents become your golden model in which your implementation is perhaps created and then checked, verified. And then I don't mean to be too far-fetched, but without any changes, it can also automatically create assertions and add those into your RTL, execute them in simulation, and prove them in formal. Again, all derived from your specifications. So we believe this is where we're headed. It's an automated design and verification activities. It's read from human specifications with oversight from human engineers. But when we go home to be with our families, the work continues. And that's the real value here. We're continuing to work with semiconductor and hardware companies interested in influencing the future of Sinfonia's development. If you're interested in joining, you can reach out on Symphonia.digital. And with that said, I think I have somehow wrapped this up earlier than I anticipated. So here is my Q&A slide. And I thank you for attending. If you would like to reach out personally, I'm happy to meet. You can reach me at planorama.design/webinar, or if you'd like to go and learn more about Symphonia Digital, you can do that as well. Daniel, I think somehow I have got done earlier than I anticipated.
Well, great. That means we'll have more time for the Q&A. So there are plenty of questions coming in.
Okay.
All right. So, but first, I actually have a question. Is this for RISC-V only?
No, it is not. We happen to be using RISC-V because it's an easily accessible specification that that many folks are interested in. But no, it does not have to be using RISC-V at all. That is just for the demo. You can bring in any specification documents for your projects, and it will work just fine.
Okay. This is a audience question. If AI has mastered the human language, math is also a formal language. How can we use Gen AI to further our mathematical understanding and thus physical, chemical, and biological understanding? So I guess they're asking for your opinion based on your experience.
Oh gosh, that's a broader question. It has mastered, you know, when you have to understand how transformers work, and transformers are at the very smallest level, they're predictive, right? And they're looking at what is the next word to provide. And there are areas that we found that they do really well as transformers. There are other areas where it is a challenge for them, and that's where we have these things like hallucinations. And they typically are not so good at math. So if you try to go and ask a basic question, like a math-related question, it doesn't do so well. However, it can do quite well at reasoning. And just by reasoning alone, you can have it start self-reflecting, looking at the answers it provided previously and going forward from those responses and trying to give you even better responses. And I know that OpenAI is working on this with their other future models where it can be a bit more introspective, learning what we've learned over the past few years. It can do better at even providing more accurate answers. And I think as we progress down that path, it will help us to find avenues where it makes more sense to use these newer models. But this is a nascent space right now, and from a commercialization perspective, it's just beginning. We're in the very early stages. This is almost like, you know, the dawning of Web 1.0 when NCSA Mosaic was out, right? And we all thought this was amazing. This is the time. This is about that same time period, I think, from an analogous perspective. And I also dated myself by saying NCSA Mosaic on the webinar, but I do think it's a very early time. But the reasoning capability is such a big deal for these language models, and the more that we can improve that capability, the more we're all going to benefit from it.
Okay, some product-related questions. How does Symphonia know to write test cases? How do they know it should write test cases in assembly language?
Well, we're providing it with documentation. So there's a couple things. We're using the language model itself, and then we're also providing it with the specification documents. And so in a retrieval augmented generation fashion, which is they call RAG these days, it's using information it has about the RISC-V ISA to know how to write the test cases because it knows the format of the test cases. It knows the format of the instructions, I'm sorry, from the documentation that we provided.
Okay. What are the what are the implications of this technology for ASIC and FPGA constraint development, timing analysis, and development for heterogeneous parallel computing systems?
Oh my gosh, that's a mouthful. And as hard as that was to get out, that's probably going to be hard enough for me to be able to answer. I can only speak right now to the design and verification side. I am sure that AI is playing and will play a role in the other aspects of design. And by the way, I think there's work to be done on a system level design point of view, and co-design I think is ripe for exploration again. I know that was a popular phrase years ago, and finding out how to design a architecture of a processor or a core or an ASIC, especially where you have that flexibility to consider, well, what is the software that's going to be run on this, and what kind of speed up do we anticipate getting by putting certain portions of that in hardware versus software, versus the power constraints. This is all ripe for automation, especially if you can have language models participate in running tests against possible design plans for this. So there's a lot here. I don't have all the answers for all of that, and that's probably a dissertation that would need to, or something that would happen over a conversation that would happen over a beer or a few. But I can tell you for RTL, what we're seeing in the software world is that this is actively being pursued. Right? This idea that you can have AI help to generate from specifications. And so ultimately it goes back to the specs. In the software world, they call them requirements, right? There's this concept of a user story, which is a kind of document that you write that contains information about the user and what they're trying to accomplish, and the screens or the process flows that they're going to go through on the screen and on your computer or on a touch screen. That is all written in English or whatever language that you're writing in. It's written, by people, and the job of the developer has always been to translate that into the code, whether that's front end code, building the UI, or back end code, the much of the predominantly containing the logic of the application. And when you look at software, that's where they're going. Is their CoPilot was built for that purpose, and it is clearly making inroads, and many open projects are pursuing a level of automation to try to bring this autonomous AI agent that develops software for you from specifications automatically, bring that to the forefront so you don't have to write code anymore. That's the goal. It's a lofty goal, but I think it's possible. In RTL, we actually have a bit of an easier time. We have really good, well-written specifications, which often are lacking in enterprise software. And we also don't need user interfaces. You don't need a UI. You're not building a UI for a chip, right? So there's a lot of aspects that can be sped up and accelerated. And at the end of the day, even though you're writing HDL, you're writing in a language, and that language can be generated by a language model. So that's my probably very windy answer to your rather short question.
Okay, what is the format of verification test plans?
What is the format? Well, what I showed on the screen earlier was a way of capturing a verification test plan in a map, Again, it's a way of just breaking down a problem into component parts. And you can use those for a variety of purposes. Doesn't need to be for verification test plans, but for the purpose of this demo, we used it for showing a test plan. However, that doesn't even need to be the primary method for capturing it. If you wanted to write a test plan in a document or a PDF and import it into Symphonia into your project, that would be equally viable. And then that becomes part of the test plan library that Symphonia has access to, along with the specification, so we can start doing that generation from there. So we're not requiring that you necessarily use that UI. However, we are building out that UI so that there's a lot of value in having that open as part of your assistant when you're working in any given project. And I do believe that in the future we'll have Symphonia being able to plug into IDEs. If you're using VS Code or any other IDE, now you can have that available to you in the context of where you are. If you're working on a certain module, like the multiplier module, it's available to you right there. So I anticipate that the UI is going to be useful, but I don't want to necessarily force people into using that UI. I want to make Symphonia future-proof, right? That's also why we're not, we're not trying to upload documents into your project in Symphonia. There's no reason to. You already have them located other places. There's no reason to duplicate. Grab the information where it's at, pull it in, and make it available so the AI can make use of it.
How much expert designer oversight is needed for the results provided here? Did you find instances of hallucination?
That's a good question. There are always going to be instances where there are potentials for hallucination. And we're not saying at this point where you should blindly go and take what it gave you and put it in to your design. You should be reviewing, and this is not Symphonia is not a permission to remove your brain and let Symphonia do all the work for you. We think eventually there will be the opportunity, especially as the models get better and as Symphonia evolves, that there will certainly be opportunities for these automated AI agents to actually start generating test cases and reviewing them and running them in simulation and seeing what kind of seeing if you're actually hitting the coverage. That's the beauty of this, is that if you have code coverage and functional coverage embedded into the process, you have a feedback loop, so it can be generating test cases and then seeing if it actually hits and refining itself as time goes by. That's not, I'm saying that's the future. I'm not saying that's what we're doing right now, but we're setting ourselves up for that. Again, language models are getting better every day. They're always going to be hallucinations, and that's why we're also, when we provide a response, we're providing links back to the documentation so you can validate it yourself and ensure that you're finding the information from the source, from the actual documentation. But we can get you there very quickly, give you an initial answer, and then take you back to where we have the source material for that answer.
Does Symphonia offer real-time suggestions as CoPilot and other coding assistants do?
Yeah, that's a good question. And that's what I was suggesting earlier, that one of our goals would be to plug this into an IDE, and VS Code is a great one, very flexible. I'm talking about Visual Studio Code. Plug it in where you would have access to the implementation, in this case, the Verilog, or it could be your test plan, or whatever your test cases are written in, have access to that immediately, so you wouldn't need to go and copy and paste in. So that's certainly the idea. But right now, and for this demo, we were just showcasing that we could paste the code in. But the goal is for this to be seamless and part of the experience of the designer and verification engineer, so they don't have to leave the environment they're already in. But we're just, we're getting there.
Can you tell us more about language models? What is the value in plugging in the different language models? And also, does Symphonia use a custom language model, or is it the one from ChatGPT?
So right now for this demo, we're using OpenAI GPT-4. The value of, and we've tested other language models too. There's positives and negatives. You know, you can run ones on your own hardware, and there's a lot of value in doing that too. First of all, the point I was trying to make with having language model flexibility is that you don't have to be married to a vendor. If you are only using OpenAI, your entire application is at their mercy, and that goes for any language model. The problem that it was with language models today, the commercial ones especially, is that you don't have control over their quality. As a language model is released, and I can remember this clearly with GPT-4, it seemed that everybody was using it, and then over time there were reports, and I read these reports, that the model was not living up to what it had done before. It is not producing the same results for the same input. Now, granted, there's an element of, it doesn't always produce the exact same result, but the quality over time seemed to be degrading. And the supposition was that they're in cost-cutting mode, or reducing or applying different safeguards to the model that are affecting the quality of the output, but perhaps are achieving other goals for them that are important as a company. But the point is, you don't have any control over that, right? When you build software, when you build hardware, when you check in RTL, you have a repository, and you know exactly what version, and you can reproduce everything. Language models are not that way. So there is a real challenge to achieving a level of quality and maintaining it over time. So that's why we built in the flexibility, not only to allow you to change and test and evaluate, and for all of us to be able to evaluate which language models provide the best benefits and the best value for the needs that we have, but also to give you the capability of having your own language models, or Symphonia hosting language models, which we've done before, and that is a steady output, right? You train, if you have a foundational model or you do a fine-tuning training of that model, you don't need to worry about it being updated or changing over time. You maintain the infrastructure for it, and if you decide to do a fine-tuning training, then you can do that and roll it out in whatever release cycle you'd like to provide for your own company. And of course, there's other benefits, like having the data never leave your premises, never leave your infrastructure, which I think a lot of people are certainly concerned about. So there's a few reasons why we're very interested in using language models that are more custom, or at least giving you the option to choose which one ones you would like to use. And I even mentioned before that we can select, have it dynamically select based on the kind of question you ask, the kind of request made, which language model is best for the job. It doesn't need to be just one. It can be plugged into multiple kinds, and then determine on the fly how to route your question or request to the right model. There might be models in the future where it's the model is internal and trained on all of your Verilog that you've ever written, all of your RTL. Obviously, you don't want that leaving the premises. That's going to be a model you're running on site or in your infrastructure, and that can be plugged into Symphonia also.
Okay, another big question. Matt, multiple groups have demonstrated use of LLMs for code generation, including Verilog and System Verilog, but these are trivial examples. To the best of my knowledge, no one has shown LLM generating, for example, synthesizable code. You see that application of Symphonia will first be in verification rather than design?
What was the last part of that question? Do I see if Symphonia will what?
Do you see that application of Symphonia will be in verification rather than design? So the first application.
Oh, I see. Well, look, if you can do it in verification, you can do it in design. I don't know what exactly the examples that you're seeing, whoever wrote this, I think it's a great question, by the way. I'm not sure what examples you may be looking at. And it's important to realize that whenever you generate, it's the first generation of the code may be what you need, or it may need to be reviewed again. And the review, as we found in the software development space, can also be done by the AI. You can tell the AI, for example, as a language model, okay, in this particular instance, you're going to be a software developer and you're an expert in Python. And so you tell the AI what it is, and then it goes and it writes Python for you as an expert. You could also tell it to be a junior developer, and it might make mistakes. But then you can go back and say, great, now you've written this, now go and review it. And now you're an expert QA engineer. And you're going to go and review and make some suggestions. And then you take that output and it goes back a third time. And it says, now, based on these suggestions, you're an expert developer. Use these suggestions to go back and refine your code. And this iterative approach, it sounds silly because you think, well, why didn't it just do it right the first time? But then again, why do software developers write bugs, right? Why don't we do it right the first time? Well, because we make mistakes, and the language models are in some ways no different. But the fact that you can use it and reuse it and reuse it and have it apply itself in different instances, this is the way that the process is going for these automated, autonomous AI agents. It's not a single pass, go generate it for me. It's multiple passes looking at it, but by the end, it's produced something that that is actual, code that can be compiled. It also turns out that you can, with the involvement of linters and even tools that will go and run execution of the code in a sandbox, that you can evaluate, hey, did it even compile or did it even execute? What were the errors? And many of the latest applications in the software world are looking at it from that perspective and feeding that back to the AI and saying, hey, this is, it didn't compile, here's the problem, here's the error, go back and fix it. And that feedback loop, that cycles and cycles and cycles, eventually generates code that is of a much higher quality. And there's no reason to believe this can't also be done in the RTL space, in the RTL design space. So no, I don't think it's just confined to verification.
Okay. How does AI assist in model checking systems? Can model checking be used for correcting AI systems?
Oh,
Another
don't
opinion.
know. I don't know.
Okay.
I haven't thought about that, but I do believe that in general, if there is a feedback loop in the process, that and that's why I drew that one image on the screen before. If we can build in feedback loops where we are generating and then running, whether it's formal or simulation, and then feeding it back and then using that information in the same way I described with the software, right? Where you use that feedback loop to make the code better, to get closer to the result that you're aiming for, to get it to compile. I think you can take that same analogy and apply it here and get closer. Again, are we there right now? No, we're not there. But I can tell you that from our viewpoint, we see that the access and availability of these specifications to the AI systems, and we've built, an AI system in the Symphonia, and there's other places to build it into as well. As I mentioned before about these agents, right? That is there is a room for future expansion, future extensibility here that I think is really exciting and can lead to exactly the kind of cases that and advantages that you're talking about, that value. But it does depend on getting all of your information accessible into a single place where that can be referred to. That becomes your golden model. That becomes your golden spec.
Okay. One final question. We're just about out of time.
Sure.
How does Sinfonia translate into downstream activities like embedded and software development?
That's a good question. So we just talked about RTL design. We talked about verification, but of course there's embedded development as well. There's writing device drivers. There's writing, everything downstream from the process. again, if you have your specifications in place, the same types of activities I spoke about, well, you could talk about how to write drivers if you train a model that is focused specifically on writing drivers, right, and how to do that. And you feed, and it has access to the specifications for the ISA. Now you have the possibility of automated driver development, at least getting you started, getting you ahead, instead of starting from scratch. So, I think that, again, capturing the hub, the source of truth for how a processor, for how an SoC, for how this product is going to work, whether it's in software or eventually you're getting into whether it's in hardware and then eventually getting into the software, that is going to become immensely important to enable all kinds of downstream activities that become either assistive to the engineers or even automated with engineering oversight. So there's a lot of room here, I believe, for future automation that is on the horizon for the next, I'll say, the next 5 years.
Great. Excellent conversation, Matt. Thank you for participating in the SemiWiki webinar series. Thank you all, and have a good day.
Thank you.